So yeah, we're going to learn about variables, and we're going to learn how to like ask questions of the values of those variables. So when I say variable, like you know it from math probably already, but in computer science at least, a variable, you just think of it like a box, and that box holds stuff. So like you can make a variable called x that holds 42, and you can ask for x later and it will give you back 42, or you can mess with what's in the box. It doesn't have to always stay 42, right? So that's going to be the game today. It will be fun. So yeah, whenever you think of variables in computer science, it's not quite the same as as like mathematical variables. It's just a box, right? It's a box that you can put stuff in and save information for later. So a variable is just a box. And yeah, you can be like, all right, I'm going to store 1,234 in the variable called x, because now I can just say x instead of typing that back out again later. So that's pretty nice. And then you can do math with variables. You can ask for like, what's the value of x plus 1? And then you can build up cooler computations. That'll be nice. Makes our lives easier that way. And then a big thing that we're going to start with is like we're going to be able to get input from a user in our program. We can ask the user to type something like, tell me your name, tell me your favorite number or something. And that will go into its own special variable in Scratch. And so we need that to do cool stuff. Whatever their favorite number is in the input variable times like 2 or something. Okay, so we can do cool things with the values that we save for later. All right, so I think the first example I want to give you is instead of hello world this time, let's do hello your name. Let's ask the user for their name, and we'll make the Scratch cat greet that person. Greet us. All right, so let's go to scratch.mit.edu if you're not there already. Start creating. And we have our wonderful Scratch cat, who is called Sprite1 right now, and I always like to rename him. It's more fun that way. So yeah, I'd like to ask the user and for their name, and I want to print out like hello Lawton, something like that. Okay. So first of all, I'm going to be getting text from the user. I'm going to be getting their name, and there's a special word for text in computer science. If we're going to store it somewhere, it's called a string. Right? Any piece of text data we call a string, and a string is just like a bunch of characters. Right? So like stuff between quotes in Python eventually will be a string. So a string is just a bunch of characters. Think like a string of beads on like a friendship bracelet or something. And you can spell out stuff with it. There's a big difference between the string 1, 2, 3. That's just the characters 1, 2, 3 without any real meaning. There's a difference between that and the number 123. All right, that's going to come up later. I just want to spell it out right now. We'll see more information about that soon. All right, a string is not the same as a number. This is just digits that has no meaning. This is an actual number that you can do math with. All right, so we'll get there. All right, so what I'm trying to say is like when we make variables, and we're about to, variables can have different types. Like one could be a number, one could be a string. You can do different things to those types. Like if you have a number, so I don't know why this happens. I'll have to figure something out. Oh no, it's that computer's fault. All right, give me a second. Sorry, I took its mouse away. Or it can get away. No, this computer is so evil. So it turned itself back on without any input. That's the problem. Okay. No. My input. Yeah, this place is haunted. I'm just gonna force it to turn off then. Goodbye. Give me my mouse back. Sorry about this. Alright. Sure. Fun stuff. Where was I? So yeah, when you store data inside of a computer, I know this is all vague right now, I haven't given you an example yet, I will. When you store data, the values of those data matter, and the types involved could be different, potentially. Okay? Oh, like I lost this mouse somehow. Interesting. Everything's wrong today. All right, so let's do the hello your name here in just a second. All right, so I think the last thing I want to say on this slide is, yeah, if you have a number, the kinds of things you can do to numbers is like you can add them, you can multiply them. You have blocks for that in Scratch, by the way. I would like a mouse, please. No? All right, never mind. You have operators down here, like you can add two numbers, subtract numbers, multiply, divide them, and that's number operations, okay? I encourage you to like play around with this, like, all right, what's 2 plus 2? It's so hard to not have a mouse for once. 2 plus 2, you click it, it's like, that's 4. But that is number stuff. String stuff, when you have strings in your Scratch program, you can't really add them together. You can print out a string. You can have the Scratch Cat say your name. We're going to do that in a second. You can like bring together 2 strings into a bigger string, but you can't like multiply strings, if that makes sense. All right, so we're about to use a block that populates an answer variable, and that's going to be set to our name. Okay, that's our goal right now. So let's make it happen. Let's ask the user for their name and greet them. All right, so I always have to find it one day, but I think we would like our program to start when the green flag gets clicked, right? And then we should probably ask the user what their name is and store that. Do you see that in the blue section there is an ask block? Okay, and this is the secret. When you run this ask block, and it already has what's your name in it, and wait, that's perfect. When you run that block, it will fill in this little circular thing, this oval-shaped thing. This is not a code block, this is a variable now, right? It's something that can hold stuff. So if I run this ask block, if I click the green flag and type in my name, the program ends, but it is filled in answer, okay? It's filled in answer with my name. It's secretly in there, and I can click it and see the value. Very small. You can do the same on your end, right? So, yeah, that's the secret. So, does that make sense? This ask block runs, and maybe if it's my cat, like my cat's name is Alonzo, now it's set the answer block to something different. It's just a box. It's just a box that holds stuff. Okay? Does that make enough sense still? It's a little weird. So we want to ask the user for their name, and then we want to tell them, hello, your name. And for that, we need to use the join block. All right? So here's kind of what we have to do. So if I type my name in, and that's stored in the answer variable, if I want to build up a bigger string, remember the word now, bigger string of text to print back out, then here's kind of what I need to do. There's a join operator that will take 2 strings and make a bigger string. Okay, join apple and apple space, secretly there's a space there, apple space banana makes the bigger string, apple space banana. If I want to say hello Lawton, I can say hello space, or maybe comma space, and then I can put my name right there. Do you see how it fits? That's pretty nice, all right? Oh man, this room. I want to go back to AC1. You can do it. You can do it, little projector. All right. So now, if I run the program, type my name, and I click this join block. Remember, the answer has my name in it. Now it's been set, and then I am tacking on hello space at the start. And so that's what it's producing. Does that make sense? Isn't that beautiful? And now we can have the Scratch Cat say that, right, with the say block. It's up here, and as it looks, say not hello for 2 seconds, but this big thing. So we're like putting things inside of other things. This is like these oval-shaped blocks compute values. They're not actual code, but they're to be used in code blocks. Okay. So again, my name, hello, comma space Lawton. It's producing that string and telling the Scratch Cat to say that thing. Okay. We're building up bigger computation now. Or if it's my cat, hello Lonzo, it's all going to be placed in that answer variable, and whatever is there is going to be shoved together with hello comma space, and we get output. Okay. Isn't that fun? Yeah, we're still good. Because I still need one extra thing, don't I? I need that exclamation point at the end there, and I don't have it, right? So how do I get that exclamation point at the end? We can use another join block. All right, so here's kind of what we want to do. We have this bigger string, right? If we could just join that with an exclamation point at the end, right? Well, that's what we really need. So let's bring out another join block. It's like, all right, take all this and then put an exclamation point at the end. Do you see how that would produce the right answer for whoever the name was? There are options, though. There is another way to do it, because here I could have done it this way. I could have said answer exclamation point. That would have been my cat's name exclamation point. And then I could have joined the hello first, right? After I did all that. Oops. I have two options for this. Do you see the difference? You still need all the things in order, but it's like, here we're joining these things first, the exclamation point first, and then put a hello at the front. Whereas, and it produces the right answer. Whereas for this one, we're doing hello, shove that together with the answer first, and then put an exclamation point at the end of that. You see the difference? But they produce the same result, and you have a choice now. Either one works. Okay? So now, finally, I get to do the full program. Enter your name, hit enter, or click this check mark. It fills in the answer variable. We're joining together strings and variable values, which is also a string, and we're outputting a fancy result. Okay? And so this, let's put a comment here and say this is equivalent to the above. Okay? It is your choice. Questions about that? We're using variables now, saving stuff for later. And so now the program's different every time. That's exciting, right? Now we're getting input from the user and producing output. So let me save this so you can have it later. And if we are good, let's go and move on. I will eventually make a blank program, but let's do number stuff now. Let's work with number types, okay? So numbers can be like multiplied and added together, and we can do math with them. Let's make a program that produces the absolute value of whatever the user gives us. So we're going to ask the user for a number. It's going to be placed in the answer variable. And because it's a number, we can do math on it, right? Like maybe the user gives me -42, and our goal is to output +42, because that's the absolute value, okay? There's an abs block, so we'll find that, but that's a good start. And that's the new idea. And so, yeah, let's ask the user for a number again. Ask, like, what's your favorite number, or enter a number, something like that, and wait. And to start the program, instead of touching the green flag, let's do it when the sprite gets clicked, because there's different events. There's different ways of firing off stuff to happen. And so let's do it not when the green flag gets clicked, but when the sprite gets clicked. So when I click that scratch cat, it will run this code, rather than the green flag. That's a different event, all right? Enter a number and wait, and now after that block will run, I will have something in the answer variable, and I would like to compute, like maybe I type -42, like I really do. Can't click the green flag, gotta click the scratch cat now. -42, answer variable holds, -42. There is an absolute value block, it's way down here. The bottommost green thing, okay? There's actually other operations here, like you can pick other things, like sine, cosine, tangent, but we'll do the absolute value of whatever is in that answer variable. And because it's a number, it's fine, and it produces +42, okay? So I just need to print that back out. Again, we'll go up to the say block. Say that answer, please, which is this big thing, for 2 seconds, all right? So can't click the green flag, that's not the event anymore, only when I click the scratch cat. Enter your number, -42, +42. Click them again, enter a number. If it's already 42, it stays 42. Okay, so it's doing some math this time. It's a different type in the answer variable. That's the words I want you to slowly learn. I'll say them enough. Any questions about this program? It's not too bad, right? So, let's see. what do I want to teach you next? The answer variable is nice. It's something you get from the user, but eventually you'll want to make an X variable. You'll want to save extra things than just one thing. Okay, so let me show that to you. How to make your own variables. Boop. You can make custom variables, and that's orange stuff. You scroll down and look at the orange section. Let's do this. Let's make an X variable. We'll actually make an X variable for once. And we'll have it be messed with when I press the space key on the keyboard. Why not? All right. So let's, I don't know, I'll clear everything out. And if you go down here to the variables section, by default, there's one called my variable. And you could click to make your own new variable if you wanted to, call it X or whatever. Or you could use this one. If you don't like its name, you can give it a name by right-clicking and renaming it. Like, all right, I'll call that default variable, let's call it X. And so now I've got an X variable that I can use as many times as I want in my program, all right? And I can change it, I can mess with it. I can set it to something with the set block. I can like add one to it with the change block. I can print it out, show it, and hide it. And you can also see its current value always on the screen if you check the box next to it. It's like, here's X's current value. There it is. Something like that, okay? So, I think that's what I wanted to say. That the show block also does that. It shows the value there, okay? So, even if it's unchecked. Let me show you this exact program. Can you kind of see what's going to happen there? So I'm going to press space on the keyboard. That's going to start the program. That's going to be my event that starts the program. And it's going to set X to 44, let's say. And so X's value, it will now, it's a box that holds 44. What will happen then? All right, if it's 44. And then, like, you'll see it, we'll show it, and then we'll change it by 1. This change block means, like, add to it. So increment it by 1, so that'll make it, like, what, 45? And then we'll show it again. And so you should see 45 at the end of the program. Okay, that's kind of how you want to read that. So let's watch that work, because there's something that's going to go a little weird and wrong. Okay, so let's take a look at that. I'll make a new program that starts when the space key gets pressed this time. Why not? So I've got my variable X down here. I'd like to start its life off, X. I'd like you to be 44 first. 44. Why not? And then I want to show your value. So 44 should be like displayed. And then I would like to change you, Mr. X, by 1. So I'll give you 45. That'll put 45 into X. And then I want to show it again, which is kind of useless because it's already shown at that point. But if I uncheck it, if I press the space key now, it's going to run all this code, and boop, boop, boop. So it's a little small, sorry, but hopefully you're doing it too. All I see is 45. Do you have any ideas as to why? That's a little weird, right? It is 44 right here when this block runs. Like, this block legitimately sets X to 44. There it is, 44. Why don't we see 44 ever? I click it and it says 45. Yeah. It means display it right here. So, like, if it wasn't displayed, it really will work if I get rid of those other things. There's 44. Why does the addition of those two blocks immediately give me 45? It's just so fast. Good. So our computers are lightning speed, guys. They're running this code like every block takes a nanosecond or something. Okay, that's faster than your screen can refresh. Like normal screen, probably the projector is refreshing at most 60 times a second, which is significantly slower than this code can run. Okay, so that's key new idea here, right? Key new idea today. Our computers are so fast. If you want to see something as humans, and also as projector screens that don't refresh very often, you have to make your program wait. All right? Like in between right here and here. If you want to see the 44, stop right here, because like this and this take like a couple milliseconds and the screen will never refresh by the time it's done. Okay? Does that make enough sense? It's a little weird, but that's what we need to do. If we want to see the value, we better have it wait. And we have a wait block for that. We wait 1 second, sure. And so now it's stuck at 44 for a second. And you can see it there. Right? It's 44 for a second, 45. And this kind of goes back to the other day when I was saying every block that does not have a time associated with it, like say for 2 seconds or whatever, or glide and take 1 second to do it, every other block, consider it to be instantaneous. Okay? And it more or less is. Okay? And that's the secret. Any other questions about that? It's a little weird, but now we know. I'll save that so you can look at it later if you want. So we got that. I'll have to find new batteries for this mouse. That is so sad. What next? Let's make fancier programs. So we talked about variables. I want to do asking questions now. Because our programs, they're cooler today because now we can ask the user for input and do stuff with that input. Like when our program runs, it can be different every time now. We can do math on what the user wanted to do it with. We can ask the user for their name and greet them instead of just saying hello world. So we have more options now, but we're still kind of limited, all right? Because our programs, they look like this. They're just straight lines of Lego blocks. You've got some event to start to kick everything off, right? Got that event-looking block thing. And then you put a bunch of blocks underneath that. Yeah, that's what we know how to do right now. We know how to make programs that look like this. And then they all fit so nicely together. And they're cool, but they could be cooler, right? This is like do thing A, then thing B, then C, then D. Yeah. And so if I were to make like a flow chart for what's happening, it's like thing A happens first, then we immediately do thing B always, then thing C after that always, then thing D after that always, and that's it, all right? Wouldn't it be nice if we could do more than that? What if we could make fancier programs? I'll use Rainbow for this, because why not? Wouldn't it be nice if we could do this? Do one thing or another, B or C, depending on some condition, all right? And then maybe come back together and do more straight line blocks down here. That'd be cool, right? So then like we go off, do one thing, like if the user typed a small number, do this, if the user typed a big number, do that. That would be more interesting, right? And that's called a branch, which kind of makes sense, right? It's branching off, doing different one or the other thing, potentially coming back together later. And in addition to that, wouldn't it also be cool, like if I want to like have the scratch cat like move around on the screen, just walk back and forth until the end of time? I can't really do that. I have to like make a really long program, like glide to the left 1 second, glide to the right 1 second, like copy and paste that a million times. And you will eventually stop after the millionth time. Wouldn't it be cool if I didn't have to copy and paste my code as well? Wouldn't it be cool if I could do this? Like I have do thing A, then thing B. Wouldn't it be nice if I wanted to repeat things, if I could just come back, just like have those two blocks repeat themselves? That'd be nice. That would be very fancy, all right? That's called a loop, which also hopefully makes sense given the diagram, okay? So I'm going to show you both of those, and it's going to be great. That is the start. All right, so let me do a fun example. All right, so here's a silly idea. This is an example of loops. All right, so I'm about to make code that does this. Does something and does something else and repeats it. Some repetition, all right? So silly program, example of loops. Here's some code. So here is a block, a new kind of block. We're going to ask the user, like, how fast should I spin? Because you can spin your sprites, because you have these turn blocks. And that number is going to be used in this turn some degrees block. So if you type a bigger number, he'll turn faster. That'll be the idea. And we're gonna shove that into a repeat 10 block. All right. And so this is in the orange section, or I guess lighter orange section. And you can see that these blocks can have stuff inside of them. Like I can shove stuff into this repeat block. And that's the stuff that gets repeated. Okay. That's going to be the goal. All right. So let's make a new program to show that. Whee! This will be so cool. All right. So it's going to repeat. You can think of it as essentially having 10 of these blocks next to each other because I'm repeating this inside 10 times. All right. So this is, before we actually code it up, this is the number of times to repeat the inner code. Repeat the inner code, and then this is the block, or whatever you put in here. It could be multiple things. Whatever you put in there gets run exactly that many times. So this will get run 10 times. All right, I hope you can read that. And now let's watch it work, because it's exciting. So let's do it, what did I say, up arrow? Why not? So this time the program will start not when the space key gets pressed, but when I press the up arrow. Okay? What do I want to have happen? I would like to ask the user for a number. How fast should I spin? Should I spin like 10 degrees every time I spin, or should I spin 20 degrees every time? You tell me, user. And then I will have in the answer block some number after that, like a percentage of how fast, like how many miles per hour should I spin or something. That's kind of how you can think of it. And then I would like to have this, let's see, this turn, let's say, right a certain number of degrees block in here, right? And I'll eventually put it into the repeat block. But do you see how if I turn 15 degrees, if I just click it, the scratch cat, every time I click it, he spins exactly 15 degrees, right? If I make him spin 25 degrees instead every time I click it, he's spinning more. 35, it hopefully is kind of obvious that he's spinning a lot more every time I click it, because he's got more ground to cover, more degrees involved there. Or if I tell him to spin only 5 degrees every time I click and run that block, he's not spinning by very much. Yeah. So let me put him back to normal direction. I don't know, 90. Get it exactly there. Direction 90. So do you see how if I typed a number and I use that to be the degrees that I turn by, if I type a small number, he'll turn a little bit. If I type a big number, he'll turn a lot, because it's to be used for the degrees. Okay. So like, how fast should I spin? You should, oh sorry, up arrow. Turn 15 degrees. So he turns 15 degrees once. And now if I repeat that 10 times, if I go down here to the control place, repeat 10. What do I want to repeat 10 times? The turning. Hoo-hoo. Oh, the room doesn't want to see the cool program. This is so funny. What? Could be, yeah. Because it is trying to charge this and also do things at the same time. That could very well be true. Let's see. But yeah, let's do it. So up arrow, how fast should I spin? If I say 15, he's going to, like, we're going to get 15 in the answer variable. He's going to turn right 15 degrees 10 times. And the repeat block produces some animations. Like, it's clicking it really fast as it can. All right? So if I do it again, just spin 3 degrees every time. Whee! And so 10 times he spins 3 degrees, and it goes a bit slower. All right? So it's kind of controlling the speed there. If I do 25, then he's going crazy, right? If I do even more than that, 45, now he's very dizzy. Does that make enough sense? That's repeating. It's repeating this 10 times, which is so much better than the alternative, right? If before we knew this, what would we have to do? It'd be like, all right, if I want to turn that many 10 times, I got to duplicate the block 10 times. And that's disgusting, okay? It's much better to use a repeat. Whee! And so, yeah, now we have an upside down scratch cat. Let's restart the program. I don't know, spin 90 degrees at a time. Now it's back to normal. Cool, that worked. But yeah, it's essentially this repeat block is just clicking the body, or sorry, it's clicking the thing inside, which I'll give a name to eventually. It's clicking it a bunch of times, clicking it exactly 10 times. And you can control this with another variable if you wanted to. Ask the user, how many times should I spin? Have 2 things involved, okay? Let's see, I think that's what I wanted to say about this example. Are there any questions about this idea of a loop? It's pretty exciting, and I encourage you to play around with this stuff. It's fun. So now I want to go back and talk about this idea of branching. Like, all right, thing A happens first, and then I want to like do thing B or thing C, depending on something. Depending on the answer to a question, essentially. And the technical term for that in computer science is a condition, the result of a condition, all right? So we'd like to have branching happen, please, if only. And let's see how we get that. All right, so we want our program to do like one thing or another, like go down this branch or go down this branch, depending on the answer to a question that you as the programmer write. So let's say something like this. If the answer variable holds exactly 42, then if the answer is yes, it does hold 42, then do thing A. Or if the answer is no, do thing B. That's kind of what I want to be able to do, all right? So if answer is 42, if that's yes, a yes answer, then A. If it's not 42, it's a no answer to this question. Is the answer 42? Maybe I should say is instead of if. That would make more sense right now. Is the answer variable equal to 42? If it's yes, do thing A. If it's no, do thing B. All right, that's kind of what I want to be able to do. And this question is called a condition. All right, a condition that will go and determine if the answer is yes or the answer is no. Okay, so that's perfect. And so we'll do those things, and then we can eventually come back later once we're done doing our specific stuff. All right, so I'm going to show you how to write that kind of code. To get there, though, we need a new kind of data. So I talked about you can have numbers in Scratch, and you can do math with those numbers. You can have strings in Scratch, and like you can print them out. You can make bigger strings so that you can eventually print those out. That's just a bunch of characters at once. There's a third thing that we need to understand right now. It's called a Boolean. That's named after George Boole, who I talked about on the very first day of class. Remember that? But a Boolean, or bool for short, is a value that's either true or false. That's our yes or no in computer science. All right. So when we ask this kind of question, like is answer less than 0, is it exactly equal to 42? We want to do something when the answer is yes, and as computer scientists, we say when that condition is true, we want to do that thing. All right. So yes, the word yes for us means true, and no is false. All right. Just slightly new terminology, though you know these words. That's going to give us what we need here, because you have these blocks. I sure hope I saved this. We'll find out. Dun, dun, dun. You have these blocks down here, operators. You see how there's a less than block, and it's pointy, because that's like the third kind of type. Like is 25 less than 50? The pointiness means it's going to produce a Boolean value. It's going to produce yes or no, true or false. So I click this. Is 25 less than 50? The answer is yes, so it's going to say true. All right, Scratch will compute that for me. Is 55 less than 50? False. And so the answer is no. Okay, so the pointy ones, the pointy things, give you yes or no answers back, true or false answers back. All right, and so with that, here's my silly example. Let's do that absolute value program again. All right, I'm going to force you to try it in a second, but I'm going to give you everything you need to do it. All right, I'm going to have you try it eventually, though. So here's the secret. Here's kind of the program. If you could do absolute value without using the abs block, because like that's cheating, it's already done for you. If you didn't have the abs block, you could have used this idea of asking a question and branching. All right, and let me show you how. So like maybe we ask the user for the input first of all. Like this is what the program needs to look like. We get the input from the user, and we want to take the absolute value of that input. So like the answer variable holds the answer. Maybe we type -42. Do you see how you could ask a question and do math on the answer to produce the correct absolute value? Always. So here's what you could ask. You'd be like, all right, you know the absolute value of a negative number becomes positive, right? That's kind of what absolute value is. If it's already 0 or positive, you don't change it, right? Those are your two branches. Is it 0 or positive? If so, leave it alone. Is it negative? If so, make it positive. That's what absolute value means. So like that's the question you need to ask, and that will go in a pointy block, right? So like is the input, which goes in the answer variable, is that less than 0? All right, pointy block. And if it's true that it is less than 0, like you do have -42, what do you need to do to produce positive 42, right? And it should always work. Don't just like hard code it. Like maybe it was -55 rather than -42. How do you make a negative number positive with math, right? What could I do here? Yeah, do something like that. Multiply it by -1. You could like subtract it from 0. That's also a valid answer. Like that would make it positive, right? Multiply by -1, and then we're ready to display our answer because now I have it. I have the answer. Display. All right. So that if we go down this branch, it's going to make a negative thing positive, right? If it was true, it was negative. We're going to make it positive by multiplying by -1. If it was false, right? If this answer to this question was false, no, the input was not less than 0. That means it was either equal to 0 or bigger, right? And so in that case, it's already positive or 0, and in that case, we're done, right? We can just immediately display the number. It's already, the absolute value is done. Absolute value of a non-negative number is that same number. Display the number, and we are good to go, okay? So those are the two things, the two ideas, the two branches, okay? Can we all kind of imagine both sides of this coin? Like, all right, the answer was 42. We'll ask the question, go down this branch, and say 42 back, because that is the absolute value. Or if it was -42, we'll hit this way and output positive 42. You see how both ways will work, and they will produce the correct answer. So that is what I want to write code for. And the secret, the way to do this, the way to ask the question, and the way to get this branch stuff going is to use this block, this if, then, else block, all right? You can see that it takes a pointy thing. It takes a Boolean value, all right? Something that results in a yes or no, true or false kind of answer. And then it has two sections, a then section, right? A then section and an else section. All right, and let me explain that now. This is your if, then, else block. And so here is where you put your pointy thing. This is where you put your condition, the thing that will eventually result in yes or no. Condition goes here. It must either become true or false, and Scratch is forcing that to happen because only pointy things, every pointy thing becomes true or false. Must turn into true or false. Okay, that is the secret. And then you have two things, two sections, all right? You have this first section, the then section, and you can put as many blocks in here as you want. I'll call that like section number 1. And you have this else section, section number 2, all right? You kind of read it as like, if this condition is true, do thing 1, otherwise else do thing 2, okay? So all the code you put here is run, is executed, if the condition, I'll say conned for condition, if it is true. So that means it is the right answer. The answer was yes, all right, if it's true. And then this code happens in the opposite case, if the condition was false. Executed if conned is false. Okay, and there are correct terms for these. This is called the true branch, this section, and this is called the false branch. Kind of makes sense, right? We're running the true stuff, so this is called the true branch. Let me spell that better. True branch. And this is the false branch. So do you see how you do one thing or another depending on what you put in there? And then, like, once this whole thing is done, it's done one side or another, you can come back to stuff down here that can go in order again. Okay? That's the secret to it all. So this block, essentially, in the diagrams that I've been writing to you, for you right now, kind of looks like this. You have your condition. It'll check if it's true or false, T or F. And if it's true, it does all the stuff in section number 1. And if it's false, it does all the stuff in section number 2, the false branch. True branch versus false branch. That's how this runs. Okay? Any questions about this before I give you a short example? And then I'm going to ask you to try. All right, I think I need to make a new program for sure. But here's kind of an example. All right, so here's a very quick example. I don't know, if 25 is equal to 50, and it never is, then, I don't know, let's say stuff. Say true branch or false branch. All right. So I'm just going to click it to run it. I'll be lazy about it. But is 25 equal to 50? No. So the answer is always going to be false, right? And so it's going to hit always this else branch, this false branch. You see that? If the answer is true, if it's yes, if 50 is equal to 50, that is finally true. That's always true. If I put that as my condition. Yeah. One day they'll let me connect wirelessly to this projector, but they're taking their sweet time. There we go. So yeah, now I'm in the true branch always. Any questions about that? It's pretty cool, right? Let's see. And then once everything's done, like you go down one side or the other side, then you can put just more code down here. This always gets run, like hello. So it says true branch and then hello always. Did I do it wrong? True branch. Hello. There it goes. And like if I said is 2 equal to 50, it will run the other branch, the false branch, and then it's done with the whole if else. Then it'll still say hello. Okay. So I think that's everything that I wanted to show you. Are you ready to try to make the absolute value program? Because I want you to try. So here is everything that you need. Here is our setup here. Boop. That's what you need to turn into code. Try it. All right, so create. I'll give you a few minutes to try it and ask questions if you're having trouble. Help the people around you, for sure. That can help too. But I'd like you to try to make this absolute value program without the apps block. Try to translate this into code with the if then else and see if you can get it working. All right. And if you can do it quickly, maybe try using a variable of your own choosing, like use the x variable or something and like change it or something like that, rather than just going through answer. But try it with the answer variable first, all right? Because that'll be the easiest thing. You gotta look at what's inside your answer variable. What's in there? Is it positive? Is it negative? Could be negative, for example. All right. So yeah, we got plenty of time. Make sure you're doing attendance as well. If you didn't do attendance, I'll stop that after we do this. In the meantime, let's see if I can get a working mouse. Well, that may have fixed it. Maybe not. We'll never know. Step one is going to be the ask block, right? Hey, give me that number, please. Let me talk kind of what you could do to fix that. You'd have to go through your own special variable. You're always getting the answer in the answer variable, but the second you get it, you can like shove it into your own x variable or something. And then you have total control over those variables. Okay? I think that's what you want. You can like reset this variable to positive 42. wait around a couple more minutes and we'll come back together. No, this doesn't work. Oh. Yeah, if you finish, try to use your own special x variable or something. Try to put the answer into an x variable and like change x, because you can't change the answer variable sadly unless you use ask again. But you can change your own x variable, because then the program might get a little different. Nice. Alright, that was my timer. Were there any questions that came up as we were trying to do this? Did we all figure it out? Well, let's do it together now. Let's, I don't know. Let's go finally back to the green flag. When the green flag gets clicked, please ask the user for a number. That's in sensing. Ask, enter a number, like a colon or something. Make it pretty. And then we'll use that answer variable. So if what the user types was negative, so I'll go down to operators, drag out this guy. If answer was less than 0, there's my question. If that answer is yes, it was less than 0, it's negative, like it was negative 42, then I want to print out positive 42 by multiplying by negative 1. All right, take answer. It's all over the place, I know. Take answer, multiply it by negative 1. That will negate it, make it back to be positive, and I can print that out with like a say block. All right, boop, something like that. Or if this was false, right? If it wasn't less than 0, then it was positive or 0 already. We're good to go. Then I can just say whatever was in answer. It's already its own absolute value. All right, so I can just say answer for 2 seconds in that case. So it's one case or the other. All right. So enter a number, negative 42, prints positive 42 because it went down the true branch. And then enter a number, positive 42, still prints positive 42 because we went down the false branch. We didn't need to negate it. Okay? Any questions about that? Is that what we got? Not too bad, right? So there's that way. You could also play around with using your own variables. So let me show you that way too. I don't know, let's do alternative version. When we click the sprite, I'll duplicate all this and slightly change it. So here's a different way to do it. I could say, or maybe let me add a comment so that you know what I'm doing. Alternative, if you download this later, alternative version with variables, with a custom x variable. All right, so we can make our own variables. We get this default one. You can make your own by clicking this button, giving it a name, or I can just rename this default one because it's not doing anything for us at the moment. And so here's what I could do. Here's another idea. If answer is less than 0, I can do something. If answer is not less than 0, I can do something. But how about I work with x instead? If I check x first. So this ask block, what it does is it always places the answer in the answer variable. But I can never change the answer variable. There's no way to do that. There's no like set answer to whatever I want, change answer by something, some offset amount. But I can do that for my own variables like x. So instead of the way we're doing it here, I could say, all right, after I get that number, I know it's in the answer variable, I'm going to take whatever that number is, and I'm going to shove it into x. All right. So what just happened was this. Boop. This is what I just did. I got the answer from the user, and I just placed whatever was in answer into that x variable. All right, that's what I do. So now, instead of answer all over the place, now I can use x because x holds answer. Does that make sense? If x is less than 0 now, I can ask about it x because x is holding the same value right now. And I can do some different things. Oh gosh, I did not mean to do that. I'll eventually say something. And so now, watch what I could do. I could say, all right, if x is less than 0, I have the ability to change what's in x. I could do this. I can be like, all right, x, become positive 42 now. Wouldn't that be interesting? I could say, all right, whatever x is, if it's less than 0, I want to set it to be its negated version. So I'd like to set x to be x times, like its old value. This is kind of a little weird. Its old value times -1. Oops. So you're using the variable to change itself, which is a more complicated topic for sure. So if x is less than 0, like it's -42, then I can set x to be something different, but in terms of its old self. Set x to be its old value times -1, because it'll take that, shove it back into x, okay? And that will now make it positive. And then otherwise, if that was already good, we actually don't need to do anything in the else case, because now we can just like let it finish, let it hit this if it needs to, and make x positive. And now x is guaranteed to be positive down here. I don't even need the else. Isn't that cool? And when you don't need the else, you can just do an if then. If it's negative, mess with it. Otherwise, do nothing at all. And that is another way to do the same program. I put the variable, I put the value that I got from the user in the x variable, and I mess with that x variable if it needs to be changed. Okay? And so let's click the sprite, enter in -42, -42. I get positive 42 out through that x variable. You can kind of watch it change if we put a wait block. There's that, and then like if I type positive 42, this entire if then skips over itself. Like this is a no. If positive 42 is not, it skips over it all. It goes straight to saying whatever was already there. Okay. So definitely, if that is a little fuzzy in your brain at the moment, try to stare at this. I'm giving you all this code. See if you can understand why it's the same as this probably easier to understand original version. Okay? I think that's all that I wanted to say about that. Any questions about either of these two pieces of code? I know absolute value isn't the most fun thing in the world, but it's useful to explain this stuff. All right, so I'm giving you all this, and I promised I would stop that. Cool. And I think that is all the programs that I want to write for you today. So let me give you your next programming assignment, and there's time to start on it if you want to. So here is that. Programming assignment 1 this time. Question? Yep. Exactly. Or a custom assignment if you don't like Racket, if you discovered that. So yeah, this will be due, I think, in another week, right? 29th? Yeah, so week and a day again, just like last week when I released an assignment. Got like a week to do it. But here's my silly example assignment for you guys to do. So I'd like you to make a teleporting assignment to get practice with a lot of the stuff that we talked about today. All right, so for this one, you're going to teleport the Scratch Cat when it gets clicked. All right, so when you click your sprite, could be the Scratch Cat in your program, could be something completely different. You get to choose, but it can't start when you click the green flag. It's got to be when the sprite gets clicked. All right. What I'd like to have happen is this: make your sprite, whatever it was, teleport to a random place on the screen if you look carefully, there is a block for that. It's in motion. Do you see that there is a teleportation kind of block? There's actually a couple. It's there, all right? It has the word random in it. So you'll use that. Where am I? I'm here. And then you will have your sprites like become sentient and check where they are, all right? Because when you teleport randomly, your little character is either like in the top half of the screen or the bottom half of the screen, right? When you teleport randomly, when you find that block that does that. Like if the scratch cat's way up here, do you see how his y coordinate is a positive number? You see when he's down here, his y coordinate is a negative number? You can ask about your sprites. You can ask about your sprite's position, that you can get that. That's somewhere here. I think is it in looks probably? Oh, is it in motion? That would also make a lot of sense. There it is. So you can ask for your sprite's x position or y position. And for this example, you're going to need to use the y position because that will always be set to whatever your current sprite's y coordinate is. And you'll be checking like, am I in the top half of the screen? Like, is it a positive number? Or am I in the lower half of the screen? Like, is it negative or 0? Does that make sense? So you have that ability now. And so you're going to look at that y equals 0 line. All right. And if your sprite landed above, I'd like you to have your program output, your character to say something to that effect. Like, I'm in the top half of the screen. I'm above the middle line or something. Something like that. Like, have it understand that it got up there. That's me forcing you to do a conditional and a branch. Okay? So like, if your sprite randomly teleported to right here after you clicked it, it needs to say, like, I'm in the upper half of the screen, or I'm above the y equals 0 line. Whatever you want to say that makes it clear that you know that they are there, right? Like, I'm in the upper half, right? Or if they like teleported down here somewhere where their y coordinate was very small, negative, but potentially, then you'll have them output, I'm in the lower half of the screen. Do you see how that is going to correspond to a conditional based on the coordinates where you live, where your sprite is living after they teleport? So yeah, you click the sprite, teleports to a certain spot, you're going to inspect its y location and have it say where it is, all right? And please, like that's like the bare minimum. Go and have fun because there's plenty more things that you can do. Like when you teleport, after you teleport, there's like fun things that you can play. There's always like there's little sounds that each sprite gets. You can like record your own popping sound if you want. But there's like a meow sound that's by default with the scratch cat. There's more. You can like record your own like something. I don't know. That's like a popping sound, and that's like you teleported. Make it fun for yourself. All right. So I think that's how I wanted to explain that. So if you've never programmed before, you're in that group of students, that is what I want you to do. You are required to do the following, right? I'm forcing you to use a teleportation block, so a block that contains the word random, and then I'm forcing you to use an if-then-else block, all right? Any questions about that version of programming assignment 1? And if that is at all confusing, I recorded a little example. I didn't show you the code, but like here's kind of what should happen, all right? Again, it shouldn't work when the green flag gets clicked like I'm doing. You have to do it when the sprite gets clicked. But you can kind of see what's happening. Like they're teleporting, like I'm above the line. I'm eventually below the line after they teleport. So that's kind of how your program should work, all right? But again, when it gets clicked, so I'll mark you down if it's green flag, all right? So that's that program. And what I'd like you to do to prove to me that it's working, I'd like you to record your program. Okay? This is how I'm going to grade for every other programming assignment from now on in this class. All right? I'd like you to upload a video of your program running with your voice so that like you can show me what's working. Right? Tell me what's happening. It doesn't have to be a long video. It could be like a 30-second video. That is totally fine. All right? You can record it with whatever you need to record it with. There's this program that I use for class is called OBS. It's a popular one. I can help you with it. You can record it with your phone if you need to. And then like Zoom, I assume most of us have that installed on our computers. You can like make your own Zoom session, and then you can share your screen and click record to my computer, and that's another way to do it. Okay, so one way or another, get your stuff recorded. I'm happy to help, but what I want to see is your code, your program running, and everything happening. All right, I'll eventually ask you to like explain your program, but this one's kind of self-explanatory. Yeah, it's a free program. If this time, like this is too fast, you couldn't figure out how to record this time, then just give me a bunch of screenshots. One, your code, the program doing the first thing, the program doing the other thing. But I'm going to require video recordings starting next assignment, all right? So go get a laptop from the library if you need to or something, okay? So we're all aware of this. We're going to eventually need to record ourselves. Yeah. And it's okay if we use VS Code or we have to use the doctor? Oh, no, whatever you want, whatever I can see the output in. Yeah. And so, yeah, for those of you who want to do the Racket assignment, if you've programmed before, you're either doing a custom assignment or you're doing this Racket thing. Here's what I have planned for you if you don't want to do your own thing. So read these chapters. I assume you have Dr. Racket installed by now. And then go and do exercise 5. I think that's in 1.4. And yeah, you'll get to do a cool thing, learn some cool, weird programming language stuff. And yeah, again, I want you to record a video. Explain your program, how you got to that answer, and show me the code. Okay? So yeah, that's kind of what programming assignments are going to be like from now on. Any questions about that? All right, so I think that's everything I wanted to tell you. So yeah, the rest of the time is yours to get started or ask questions, and I'll be here at least.